Hello, Algebra 2 students. Today we are going to learn how to graph equations of lines. This is section 2.3. The parent function is the most basic function of a family of functions with shared characteristics. Remember last time we learned about function notation as f of x. It's a fancy way of saying y, and it could be g of x or w of x or t of x, anything other than y, but it still represents y, the output. The parent function for the family of all linear functions is y equals x. Well, y equals x is the equation. We can write it as f of x. In this particular function, the y-intercept of that graph is at 0, 0, the origin. And then the slope of the line is 1, because from this point to get to any other point is always going to be a 1-to-1, 1/1 ratio. So you go up 1 and then right 1. So the rise is 1 and the run is 1, so it's 1. So the y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. The y-intercept of the line that is shown on the right is 0, or just 0, 0. Oops, I meant to write that over here. So go ahead and erase that. Erase this dot that's bothering me too. Okay. One of the ways that we graph an equation of a line is using the slope-intercept form. It's the form that I feel that students are most comfortable with. The slope-intercept form of a linear equation is y equals mx plus b. Where m is the slope and b is the y-intercept. To graph a line from slope-intercept form, there are several steps we need to follow. First, we want to make sure that the equation is in y equals mx plus b form. Next, we want to identify the y-intercept. And use it to plot the point 0, comma b. So whatever the y-intercept is, which is b, you're always going to start at 0 and then go up or down on the y-axis. Next, you're going to identify the slope. And remember, slope is m. As a fraction, and we're going to use it to plot a second point. The reason why we want to use it, write it as a fraction, is because it's rise over run. The numerator is the vertical movement, because remember, rise means vertical. Positive means move up, and negative means move down, so negative vertical change. The denominator is the horizontal movement. It's the run. Positive means you're moving to the right, and negative means you're moving to the left. And that's how you graph an equation in slope-intercept form. We are going to do 2 examples. Now, you should be able to do this without the use of a graphing calculator. So let's do what we need to do. This equation is already in y equals mx plus b form because y is on the left side. The value, the fraction, or the coefficient in front of x is -3/2. So I'm just going to box it in just to show you. This is our slope. should label this in your notes. The slope is not negative 3 over 2 times x, it's just negative 3 over 2. The y-intercept, remember the sign goes with, oops, I probably shouldn't have. Oh, that is the y-intercept. Okay, so b is 1, or we write it better as 0, comma 1, so you know that it's a point that you're going to plot. The slope, we're going to write as a fraction, negative 3 over 2. Not as a mixed number, but a fraction. So now we are going to graph it. We're going to plot the y-intercept. So stay at 0, go up 1. And now we are going to use the slope to plot additional points. Negative 3 means go down, and a positive 2 means move right. And all you're doing is you're moving. So from this point, you're going to go down 3, 1, 2, 3, and then you're going to go right 2, 1, 2. You're going to repeat again, 1, 2, 3. Now, what about if you started back at the y-intercept and going the opposite directions? Well, going the opposite direction, you would go up 3 and then left 2. So 1, 2, 3. You wouldn't go the other way or you wouldn't have a straight line. And now you're going to connect the dots. And there's your equation without making a table. How easy is that? It really takes less time to do it this way than making a table and having to show your work and all that good stuff. So this is a lot easier if the equation is in y equals mx plus b form. Second example, so if we look at this one, the slope m is 3 and negative 2 is our y-intercept. So y-intercept, slope. So b is what we want to identify first because that's an actual point we plot. And slope, we're going to write it as a fraction. So if it's an integer, you just write it over 1. So 3 over 1. Let's plot the y-intercept. Stay at 0, go down 2. You know, a lot of my students in Algebra 1 would always plot the y-intercept on the x-axis. And it always blew my mind why they would do that. When it's called y-intercept, it should be on the y-axis. So start at 0, negative 2, and then go up 3, right 1. Or down 3, left 1. So 1, 2, 3, right 1, 1, 2, 3, right 1, running out of room, go back to the y-intercept and go down 3, left 1. Do we have to plot all these points? You really only need 3 points to create your line. But if you're like me, you want to use your whole space. And there you have it. That is graphing linear equations in slope-intercept form. If you go to the back of your notes, another form is the standard form of a line. It's also known as the standard form. And it's useful in its own right. It's useful when equation is not written in y equals mx plus b, and instead when it is written in standard form, which is capital A, little x, plus capital B, little y, equals c. Now, a, b, and c are integers, meaning they are not fractions, they are not decimals, they're positive or negative whole numbers. And a and b are both not 0. One of them could be 0, but not both. Number 2, identify the x-intercept. So the reason why this graph is useful is if x and y are both on the left side of your equation, like they are here, and the constants on the right side, it's really easy to find the x and y intercept. So we identify the x-intercept by substituting 0 for y and then solving for x. The x-intercept is a point where the line crosses the x-axis. So if I were to make a coordinate plane here, a simple one, and I drew a line that looks something like this, this point right here would be the x-intercept because that's where the line touches the x-axis. Okay, and then we identify the y-intercept by substituting 0 for x and solving for y because you want the y-intercept. The y-intercept is a point where the line crosses the y-axis. So if I were to sketch this, mm, this point right here is the y-intercept because it touches the y-axis. Now we would connect those 2 points. We would connect the x-intercept and the y-intercept with a straight line to graph the line. This is one of the few times that you can actually get away with only plotting 2 points and connecting them with a line. So let's do 2 examples. We're going to graph lines in standard form. Graph the line 2x plus 3y equals 12. So it's really wise to make a chart. And I notice it's in standard form because the x and y are on the left side of the equal sign and the constant is on the right side. So I make a chart. That's really helpful to me. So we're going to find the x-intercept first. And remember, to find x, you have to let y equal 0. You don't let y equal 7 or 10 or something. You just let it equal 0. So let's go to our equation. 2x plus 3 times 0 equals 12. 2x, well, 3 times 0 is just 0, so just ignore it, equals 12. Divide by 2. X equals 6. Now, what does that really mean? So, as an ordered pair, x comes first, which is 6, and remember, y was 0. We let it equal 0. So, we are going to plot 6, 0 on our graph. So, we don't have enough room here. So, instead of plotting it outside of our graph, let's scale this. Let's change that to 2. So it's 2, 4, 6. This would be 6, 0. And now let's find the y-intercept. Okay. So the y-intercept, you let x equals 0. I'm going to put a space here, or a bar, so I'm not running into everything. So our equation is 2 times, replace x with 0, plus 3y equals 12. You don't let both x and y equal 0, because then you can't solve for y. So that is 0. So 3y equals 12. Divide by 3. Y equals 4. And as an ordered pair, you do not write 4 first. You always put x first. X is 4. Y is 0. And now you plot 0, 4. Going up by 2 is 2, 4. And we're going to connect the line. Hopefully you do a better job than I do in connecting the dots. But that's your graph. Let's do one more of the standard form, and then we'll talk about our last form. Okay, so for this particular one, it's already in standard form. X and y are on the left side. So we're going to find the x-intercept first. Let y equal 0. Yeah. And so that would be, 4x plus, or I'm sorry, minus, it's a minus right there, 2 times 0 equals negative 6. 4x, 0 times anything, 0, so you just ignore it. Divide by 4. And I noticed a lot of you on your test did not reduce your fractions, and you really need to. That's very simple to do, and it's not hard. It just takes one extra step. So 6 and 4, you can divide top and bottom by 2, so you get negative 3 over 2. And so that is negative 3 over 2, comma 0. Now, negative 3 over 2 is just negative 1.5. And it really helps to think of it in decimal form when you're actually plotting it on a coordinate plane. So here's negative 1, and halfway between negative 1 and 2 is negative 1.5, right there. And now let's find the y-intercept. Okay. Make this little nicer looking here. I write too big. So for the y-intercept, you let x equals 0. Okay, so 4 times 0 minus 2y equals negative 6. And here's a problem that I also saw with students, and this was so often. 4 times 0 is 0, so you don't have to put anything there. But that is not a positive 2y, that is a negative 2y. You can't just go and drop your signs just because you feel like it, because then you're going to get your answer wrong. Divide by negative 2. A negative divided by negative is a positive. Y equals 3. So that is 0, comma 3. And so when we're going to graph that, that'd be 1, 2, 3. Connect those 2 points with a line, and you are done. And that is the standard form. So standard form is convenient if it's written in the right form. If it's not, use slope-intercept form. Okay, our last special types of lines are, our last lines that we're going to graph are special lines. And they only have one variable. They don't have both x and y like slope-intercept or standard form. So for special lines, you just make a table. That's the best way to do it. So make a table. Don't try and take a shortcut. Just do a table because it makes sense. So if we're making a table, it doesn't even take very long to make the table actually. Okay. And notice, pay attention to the equation. Y equals 2. What is y? Y is 2. Y can only be 2. It can never be any number. So we already know the number for y is going to be 2. Therefore, x can be any number you want. So any number. So for instance, you could pick, let's pick negative and positive numbers because that's good. -1, -2, 0, 3. Now let's plot that. So we have -1, comma 2, -2, comma 2, 0, comma 2, 3, comma 2, and you get the point. Connect the dots, and I hope you notice that you have a horizontal line. There you go. So the graph of y equals c, where c is any number, is always going to be a horizontal line. And it's going to go through that number. So whatever this number is what is going to be the second number. It's going to be your y-intercept basically. So if you plot that number first and graph a horizontal line through it, you would know. But I tell my students to always make a table because you can always fall back to a table. Okay, the next one is x equals -3. Oops, started going crooked there. Didn't want that. So x, y, 1, 2, 3. This time, x is -3, and y can be any number you want it to be. I wouldn't pick something like 1,000 because for one thing, it's not going to fit on your graph. So let's just pick small numbers that are negative and positive. So -1, 0, 4. It's because I feel like that. So -3, -1. Go left 3, down 1. -3, 0. And then -3, positive 4. And hopefully notice that you have a vertical line. And here's what students think. Students think, oh, it's x equals -3. It's going to be a horizontal line because I see the letter x there. Not true. So you want to graph it. I cannot tell you how much and how important that is. Okay, the graph of x equals c is a vertical line. It's opposite of what you would think. And it goes through the point c comma 0. You don't have to know any of this junk that I just mentioned, but you do need to know to make a table. Okay, now let's end with a word problem. The value of a copier is decreasing $600 per year. Anytime you see numbers, that's important. If you purchased a copier for $4,000, write an equation to represent the situation. So your starting cost is $4,000. So that would be your Y-intercept. Your Y-intercept is always your starting value. Okay. It's decreasing $600 every year. So if you started with $4,000 that you paid for, the next year it would be $3,400. The next year after that would be $2,800. It would decrease by $600 each year. So decreasing per year, that is the slope, that is a rate of change. Let y equals the cost and x equal number of years. So we are going to write our equation. So remember, if 600 is our slope, it's our m, and this is our b. And so we can write the equation and y equals mx plus b. So in part A, y equals m is negative because it's decreasing. So negative $600. Well, we're not going to put a dollar sign in there. Times the variable x, the input, plus our starting cost, 4,000. And that's all you had to do. For the graph, since, let's see, we don't need to go out that far, but I say when we make the graph, and this is the hardest part for me, is to make it nice and neat, we should scale our horizontal axis to about 8 or so. So let me do it first before you start. So 0, 1, 2, 3, actually 4. You want to try and be as close as even as possible. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just because I felt like it. So I'm going to label it 0, 2, 4, 6. And your horizontal axis is the number of years. Always label your graphs, always. And your vertical axis is going to be the cost of the copier over the time or during the change of time. And cost is going to be in dollars. And we know it started at 1,000, so we can go by 500s and say 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000. So this will be 4,000. This will be 1,000, 2,000, 3,000, and there you have it. So let's plot this. So at the initial time times 0, it costs $4,000. So we're going to plot a point right there. And I'll do a different color. Or thought I would do a different color. There we go. And then in the first year after, we said that it would decrease by 600. So 4,000 minus 600 is 3,400. So almost right there. Okay. The next year, in year 2, it'll be 2,800. There's 500 right around there, more or less. Next year, it'll be 2,200. There's 2000, there's 2500, so kind of right in between. Okay, and then the year after, it'd be 1600. There's 1500, just a little over. Okay, 1600 minus 600 is 1000. And then 1000 minus 600 is 400. Uh, and year 7, well, then it gets negative, so we don't know. Well, 400 minus 600 is negative 200, so it'd be a little down here. So if we continued this and draw the picture, somewhere over here, oops, would, I guess it doesn't matter, but it's asking us something else. So we did the graph. When will the copier be worth $500? Well, based on our graph, so here is, you want to find where $500 is. So I'm going to draw a line from 500 to right here. I'm going to say it's going to be 5.9 years about, and that makes sense. So based on our graph, the copier, so part C, I guess I can, copier will be worth $500 in about 5.9 years. Now let's find the exact amount. So and I don't have much room here, so I am going to try and put this on here to the best of my ability. So 500, when will it be worth 500? So the slope was negative 600 times x plus the initial cost. We want to subtract 4,000 on each side. It's negative 3,500 equals negative 600x. Divide by negative 600. I did the math ahead of time, but if you put that in you can take off these last zeros. So negative 35 divided by negative 6 is positive. So this one, since it's real life, you can use decimals. It's about 5.83. And that's close to our 5.9 years. And some people might read it as 5.8, and it depends on how you draw your line. So there you have it. That's it for the notes for today. Have a great day, Algebra 2 students.